A very good evening to one and all. Thank you all for joining today. So, welcome to today's session. As we all know, in the recent years, frequency and intensity of natural significance that's by their nature as a spatial phenomenon. It's impacting specific geographic areas with varying degrees of severity. Addressing this multifaceted complexities of disaster requires innovative approaches that integrates spatial data, socioeconomic factors, and advanced analytical tools. Among these approaches, Geographic Information System (GIS) has emerged as a very indispensable tool for understanding, mitigating, responding disasters effectively. Very powerful framework for capturing, managing, analyzing, and visualizing the spatial data. It's by integrating location-based information with other descriptive data. GIS is a comprehensive platform for decision makers, assess risk, plan responses, and also allocate resources strategically. In response to the critical role of GIS and remote sensing in the effective disaster management, Sphere India Academy is organizing this session titled in the Introduction to GIS Remote Sensing, Core Concepts and Application in Disaster Management. It is a very wide topic, as you all know, and it's not something that can be covered in an hour session. However, we are taking a leap of faith today, and today's session we will delve into the fundamentals of GIS, application and disaster management. Our speaker will also take us through the software, giving us an understanding on how to use it. So we are thinking of the session as a very beginning, as a fundamental session where we get our participants introduced to the software and how can it be effectively used in a disaster management setting. And also, I would like to add that this is we want this to be an very engaging session. So feel free put up your questions. And as time permits, we will take that up and resolve it. So without any delay, allow me to introduce our distinguished speaker.
I think your voice is breaking.
Sure. I'll fix it in a minute. Better audible now? Can you hear me out?
Fine. We can.
All right. So I'll introduce our speaker today, Dr. Hamid Varikoden, currently serving as an advisor to Jacobs Climate and Resilience Team, providing strategic guidance on climate and disaster resilience project in Australian and New Zealand region. With his expertise, Dr. Hamid conducts comprehensive assessments and develops innovative solutions to address the challenges posed by climate change and disasters. Holding a PhD in disaster management, his research focused on assessing cyclone risk and utilizing GIS techniques to enhance disaster resilience. Please join me in welcoming our speaker today. So over to you.
Yeah. Thank you so much. Thank you so much, Hannah. Am I audible?
Yes, you're audible.
Okay. Thank you. Thank you for inviting me. So, what I'm thinking in this session is I will just give a brief idea about what's all about GIS and remote sensing for those who are very new to the subject. So the other persons who already know GIS and remote sensing, please do forgive me. So I'll be covering a basic idea about what's all about remote sensing and some basic concepts of it, and what's GIS, why it is used, what's the purpose of it. Then I'll be just showing you how to create a small maps and all, what are the components of GIS. I'll just show you I wanted to show you the GIS basic structure and all. So then I'll actually show some of the results which actually I worked on, like how did we calculate the risk, vulnerability, and hazards associated with a particular disaster. So I'll be in GIS platform. So I'll be addressing that too. So without any further delay, let's get started. Let me share my screen. Yep. Okay.
English.
Hello. Is there any questions?
No, that was some other's mic.
Okay. Okay. So, yep. So, as Henna rightly pointed out, I work as an advisor uh, at Jacobs. Jacobs is a consulting group. So I work in their climate risk and resilience team. We basically do climate risk assessments, climate hazard, vulnerability risk assessments. Plus, I do advise in some of the coastal resilience strategies in Australia and New Zealand region. So this is the kind of work which I am doing currently. So introduction to remote sensing. So like the idea of remote sensing, like can anybody tell me like what do you mean by remote sensing? What is it all about? Somebody like if they can tell me, anybody out there, or you can just uh ping in the chat. Hello.
Hello.
Yeah, sure, go on.
Sir, collecting some
Yeah.
information from a
Yes.
distance. I think remote means a distance from distance.
Exactly. Exactly. Very good. Very good. I can't see your names. Yeah. So thank you so much for that. So remote sensing is actually in a very simple term. It's actually collecting information without having a physical contact with a particular target. So even if you take a photograph and if you analyze that photograph, that actually comes under remote sensing. So it's basically the process of collecting and interpreting information about the environment from a distance. So we typically uses satellites, aircrafts, or ground-based sensors for this. For example, like our satellites are monitoring continuously the Earth's process and all. It's a part of remote sensing. Or if you fix a CCTV camera out there in your locality, that's also basically a remote sensing. So without actually be physically in contact with an object or a target, you tend to get information. So that's the basic idea about remote sensing. So why it's important? So it is important in capturing information without direct contact. So it allows monitoring of the areas, inaccessible regions, and dynamic processes. So some areas are very inaccessible, like we can't physically go out and see what's happening over here, over there. So what we do, we engage these kind of sensors and go there. So there are two types of remote sensing. Basically, we say one is passive remote sensing, so passive, and the other one is active remote sensing. In passive remote sensing, we actually tend or we actually put radiations or we throws radiation to a object, then taking their reflectance, we identify what it is like. Yeah. So it's a very basic thing in a common man's language, I'm saying. Then the other one is active remote sensing. So every object in this world have a spectral signature. Like we do emit some sort of radiations. We all emit some sort of radiation. So in active remote sensing, what we do, we actually capture that active radiations and tends to get the idea about it. So a rock's radiation will be very different from what a building emit, or a naturally derived vegetation will have a very different radiation uh, which is being emitted uh, from a concrete building or from an artificially constructed grassland. So that's how we make the difference. So while moving forward, I'll show you like how this is oriented in a GIS platform. Now coming to the GIS part. So the full form of GIS, as you know, like it's geographical information system. So GIS is actually nothing but how can I say that? Simply, we can say it's a map plus database. So you have imagine your conventional map. We everybody uses that in a physical format. So you tend to analyze that in a digital format. So it's basically a map plus database. So this is nothing but a system which is designed to capture, store, manipulate, analyze, manage, and present spatial or geographical data. Now, like, we know that GIS is actually a software in a simple thing. So it needs a hardware. For example, you need a computer for that. Then there are dedicated softwares for GIS. For example, the major softwares basically we use is like one is ArcGIS and the other one is QGIS or Quantum GIS, in which ArcGIS is actually licensed one. Like, you need to actually pay the ESRI team to work on that. But in Quantum GIS, it's license free. So I'll be showing you examples from Quantum GIS only in this session, uh, due to like license constraints. One sec, let me just. Mm, um, yep, I was trying to hide this. Sorry. Yes. Okay. So, okay, this I have already covered. Like, these are the technologies in which, we capture something. So either you can use satellite or aerial photography. Then there are unmanned aerial vehicles or drones, ground-based sensors. Now, Now, coming to the image acquisition and interpretation, we use satellite image acquisition. Various satellite captures image at a different resolutions and wavelength. I'll be telling you like what are the satellites we do have. Okay. So for example, these are some of the remote sensing satellites. One is Landsat. It's very famous, used for making land use, land cover maps. Sport is by France. We do also have a satellite called as IRS, India Remote Sensing Satellite. So NOAA, this is exclusively used for ocean monitoring. Then Iconos, so then Sentinel. So all these satellites serves for different purposes. So if you want to demarcate an area, or if you want to do land use, land covering studies, etc., you can go for a Landsat satellite. Now, okay, so this was all about remote sensing, like how we collect information from a thing which, without any physical contact. So as I told you, there are a lot of options. One is through satellite imagery. So satellites continuously orbit around the earth, as you all know. There are geospatial satellite, then there are sun synchronous, which actually orbits around the earth, like, which is having the same time period. Then there are like polar rotating satellite. There are two types, especially, basically. Then that's how we collect information from earth or whatever. Then now we want to integrate this information into something, like where we can interpret. So for that, we use the technique of GIS, Geographical Information System. Okay, so GIS is, as I told you, it's basically a software. Okay, so it has two types of data. Okay, one is spatial data, the other one is non-spatial data. So spatial data has a location component. Basically, it will be having a latitude and a longitude. Okay, non-spatial data doesn't have a spatial component. So can you give me an example for a spatial data? So can somebody give me an example for a spatial data?
GPS.
Any data, like, um, suppose you want to map all the ATMs in your town. So basically, you should have a latitude and longitude to represent that, right? So that's a spatial data. Okay.
Yes, yes, all right. Yes.
Yeah. Now you want to represent in an area like number of people who are above 50 years old. Okay. So that particular data doesn't have to be having a what do you say, a location specific thing. So that information actually goes to non-spatial data type. Okay. Anyway, I will be showing you all these things. Now there are other things. One is vector, the other one is raster. So vectors are basically uh, which represent the geographical features. Like vectors are basically like points, polygons, or lines. Like we can literally see that if it is a point data, or if it is a line data, or if it is a polygon data, or like, yeah, which has a shape. Raster datas are like, if you take a photograph in your mobile phone, and if you zoom inside, they basically consist of pixels, right? Small, the smallest degree of an information, that is called as pixel. So raster data, all the satellite imagery is what you use is of rasters, and all the things which you draw on GIS is basically the vector. I'll come to that, don't worry. So this will be the raster data in pixels. Others will be like, if it represent any particular location, that will be a vector data. Okay. Mm, okay, before going to this, let me take, can everybody see my screen?
Yes, I can.
Okay. Ram Prasad, I can't hear you. Can you come again? Hello.
Yes, sir. The screen I have received, sir.
Okay, you can see the screen, right? Thank you. Yeah. So this is a basic screen, the first screen, what you see when you open a QGIS software. Okay. Now, I want to represent, like here, if you all know, you all are familiar with Google Earth and all, right? Google Earth, Google Maps that we already use. So here you can directly access the Google Earth if you want. Okay, but this is also, I mean, this is also a map. I mean, which is being made. You don't have to. I mean, this is by default. It is coming now. If you wanna add some of the shape files, like if you want to have all the states of India, like to represent here, so that is called as a vector data because it has boundaries. It is basically a polygon. Okay, so you can add that from here, go to here, add layer, add vector layer, basically. So I have prepared some of the um, so you can see the India map has been, I mean, pasted into this particular Google Earth image. Okay. Okay. Now, if you open the attribute table, it contains every state of India. Okay. So you can select any particular state that that like, then you can do like this has a shape. Okay. I mean, it's a polygon basically. So this is a data called as a vector data basically. Okay. Are you following? Able to understand?
Yes,
Yes.
sir.
Okay. So this is a state boundary map of India. Okay. Now, if I worked in Andamans like for almost 6 to 8 years. So I wanted to represent for my PhD thesis. I was collecting information about some of the hospitals and some of the cyclone shelters in Andamans, especially in the Port Blair region. This is the Port Blair region. Okay. Now I want to put that information in this particular map. Okay. So how do I do that? So again, this is a spatial data. Okay. I mean, hospital data is a spatial data. It basically contains hospital names and the lat and long. Okay. So by default, it should fit here. So again, I'll go to layer, add layer, add vector data. So I have already created a file for this in normal, a folder for this so that I can. So this was the shelters actually I mapped out. Okay, not health, cyclone shelters. So the color is not same. So what we have to do? Wait, happen over. One sec. Give me 1 second. Okay. Sorry, guys. Like, so, yeah. Yes. Okay. Let me just to rearrange all these things. So, these are the health facilities which I have marked. You can see here these points. So these points tell you like here. Okay, there is a problem with the state boundary basically. Okay. Yes. Yeah. See these diamonds. So here you can see that these are the health facilities which I have marked. So this actually represent a spatial data which actually have the information, lat and long information. These are the names of the hospitals which we have marked. So this is an example. This is an example for a spatial data. Sorry, for a vector data and a spatial data. Okay. Now, coming to another thing, we already discussed about the raster data, which will be in the pixel formats. So again, I want to say that I want to bring an example for a raster data. One such example is a digital elevation model. Okay, in digital elevation model, it will tells you the elevation of a particular area. So we can bring one raster data here. Then let's see how we can analyze that. So taking QGIS. So here is a digital elevation model for a Kerala region. So it basically fits here. Let me just remove this. Okay. Now, while looking here, you don't get any idea. So basically, now you have to perform some arrangements here. So not this, not- yeah. Now, if you see, if you look at this table here, the height of this particular place ranges from 958 meters, that is in red color, to 2315 meters above sea level. Okay, so you can see here this place actually belongs to a region called as Munnar in Kerala. So that's how we can create, like we can see that this part is the very highly elevated region in this particular area, and this is the lowest region. So this is basically a raster data. So this is how we create, we interpret things from here. So we can do a lot of things from here, basically, like you can even see what are the streams which are coming out from a particular elevation. What are the first order streams, what are the second order streams. You can map everything, you can even map the slope, how much is the angle, everything by using this particular digital elevation model. Okay, now this is done. Now if you wanna if you have a wanna plan something like in your disaster response, how you can use this GIS basically. So you can identify a lot of features from here, right? Like you can see a road which is going. Okay. I mean, you have a lot of options that can be put as a base map for this entire GIS thing. Okay, you can either choose, this is from Wikipedia, this is called as OpenStreetMap. It's a globally available data sets, just like your Google Maps. You can either choose Google Satellite Imagery. You can directly choose Google Satellite Imagery from here. So this is basically Landsat only, which is mosaiced. Okay, you can see the features, like every feature. So you can select anything as your base maps. Okay, directly from QGIS. Okay, you can identify the features, right? So this is a grassy land. This is this is a water body for sure. These are all paddy fields. So you can choose any of your anything of your interest. You have a lot of options here. So you can choose something like Google Roads. So it will only show you like roads. Okay. This is an interesting feature that is available here. So basically, I usually uses OpenStreetMap. Okay. Now, suppose, um, let me see, like we can go to the backwaters of Kerala. Suppose here it is Vembanadu, like, okay. In case of a flood, there is a high chance that these Vembanadu Lake and the adjacent whatever streams, water bodies will get flooded. So you can have a buffer analysis here. Like you can create some of the map for yourself. For example, if you want to mark out a road, okay, so this is already present, but if you want to do it in your own, like you can actually make a road here, road test. Okay, let me save somewhere here, road test. Okay, save. You have to give a geographical projection for it. I am not going very deep into that because that's a different session. We can't cover everything. Now you want to say which, if it is a road, obviously that will be a uh, line shaped one, right? Okay. So we have created this one. Now we have to start building the roads. This is basically absolute. you can demarcate all the roads along the highway. See, yeah, along the river. So, so like that, you created a road here. This color. Yes. Oh, sorry. You have to save. Okay. So you can see this thing which you have. So like this, you can create any shape. Like you can create a buffer. Suppose if you want to see like suppose they are saying, I mean, from road, like we are assuming that like 200 meters are very critical. So you can plan accordingly. How to minimize this one? Okay. You can actually measure the distance from here in meters. So you can make kilometers over here. So suppose you are saying from road, you have to take a 2 kilometer thing. You can actually go like this up to this one. Then you can buffer it. Like from here, you can do whatever you want. Like you can, according to your intentions, you can create maps in case of emergencies. So you can make route maps, you can make emergency maps in real time while in GIS. So I think I have given you a pretty much basics of it, like the basic data structures. So you have to uh, I mean, basically what I have covered is the vector datas. Vector datas are like the datas which can be represented in the form of lines, polygons, or points. So one such thing is the spatial data, which I have shown you, the health facilities. Okay. So like the information about the hospitals. So all here all these points indicate the hospitals in Port Blair and the one in Nicobar Islands. So the other one is a raster data, which is basically a satellite imagery. I have shown you a digital elevation model where we can see how much is the elevation of a particular area that you can easily capture. Okay, now I think, yeah, I'll go back to the presentation. So far clear? Hello? Any doubts in this? Hello?
No doubt, sir. No doubt.
Anything means please do
No
ask.
doubt.
No
No doubt.
problem.
Thanks.
I mean, was it interesting?
Yes, it was.
Yeah.
Yes, sir.
Okay. Now I'll go to
It
applications in
is.
disaster preparedness. So basically, GIS is majorly used for disaster preparedness purposes. So you all know what do you mean by like disaster preparedness, in the sense we can do disaster risk assessments. Okay. So what do you mean by a disaster risk? What is it exactly about? Huh? Can somebody tell
Something
me?
that
Yeah.
something that endangers the lives of human lives.
Yeah. So disaster risk is basically what? It's like the uh, the likelihood of a disaster. Okay. So it basically comes from two things. Okay. One is hazard and the other one is vulnerability. Okay. Are you getting my point? Are you
Yes,
getting my
sir.
point? Yeah. Okay.
Yes, sir. Yes, sir.
So we need to define these two things. What is hazard and what is vulnerability? And that is very important in disaster risk assessments. Okay. For example, a hazard is a harmful phenomenon or a product or a human activity or circumstances. It may cause loss of life, injury, or other health impacts, property damage, everything. So that is called as an hazard. So I'll give you an example. Suppose you are living in a coastal site. Okay. So in the coastal region, what happens? Suppose a cyclone is coming. Okay, a cyclone is coming from uh, from an ocean, which I mean you are living. Okay, suppose Bay of Bengal. So what is the hazards associated with a cyclone? That you have to see. Okay, so that can somebody tell me what are the hazards associated with the cyclone? So you have to keep in mind that hazard is something which may cause a potential danger thing to me. What is it? What are the elements of a cyclone? Can somebody say what are the hazards associated with a cyclone?
In the chat box, somebody has written flooding.
Okay, I can't see the chat box.
Yeah, I'll read it out.
Sorry,
Somebody has
sorry.
written water and air.
Tsunami and flood.
Oh, I
Yes.
did it. Yes, tsunami. No, I'm sorry. Tsunami is by earthquakes. So one is heavy rains. Okay, heavy rains can cause damage to you, right? So that's a hazard. That's a hazard associated with cyclone. Okay. Yeah. Severe rain, then strong winds. Winds are associated with a cyclone that will cause damage to you, right? Then what is the other one? Then waterlogging, correct. Flying objects, correct. Then flooding, coastal flooding is associated with a cyclone. Yeah, tornadoes is just a name of cyclone. I mean, it's a different name for a cyclone, extreme precipitation. Yeah, thank you so much. Yeah, I hope so. People are understanding. Now coming to the vulnerability part. Vulnerability means like how much a person or a region is actually uh, the degree of exposure to that particular hazard. Okay, so how you say that? Suppose you are living you are living in a beachside or a coastal region. Okay, so you are intrinsically vulnerable to what? You are intrinsically vulnerable to cyclones, right? You are intrinsically vulnerable to cyclones plus tsunamis because your nearness to the coast indicates your vulnerability. Are you getting my point? Okay. Now, coming to the mitigation capacity or adaptive capacity. That means how much resilient you are. Okay, suppose you are staying in a beach area, but your house is bit elevated. Your house is a pakka house. Okay, so that you are increasing your mitigation capacity or adaptation capacity towards a particular hazards. So these three things comes into play when it comes to disaster risk. So risk is defined as hazard into vulnerability or exposure divided by your mitigation capacity. That means when hazard, you cannot avoid hazards, right? Because you cannot stop cyclones coming. You cannot regulate the speed of the cyclone, right? You cannot regulate the rainfall associated with the cyclone. Then comes the vulnerability. You can do something out here when it comes to vulnerability. You can actually reduce the vulnerability. Okay. So it can be socio-economical, it can be infrastructural. So it can be anything. Like if you are constructing, practicing the coastal regulation zones or whatever policies, you can reduce your vulnerability. That's how you can uh, decrease the risk. Okay. So hazards cannot be eliminated. The only thing is like you can either increase your vulnerability. If you decrease your vulnerability, your risk is more. Okay. That's the idea. Or you can increase the mitigation capacity so that your risk will be reduced. So this is the basic idea. Now, by using a remote sensing and GIS, I have done a case study in Port Blair, Andaman and Nicobar Islands. I did a cyclone risk assessment study as a part of my PhD. So I just wanted to show you how I did it. So as you all know, Andaman and Nicobars are located in the Bay of Bengal, like southeast part of India. So it's an archipelago consists of 5, 12 islands, etc. So In 2013, there was a cyclone that actually came in the category of severe, very severe cyclonic storm. Okay. So that actually crossed this region of Andaman Islands, Port Blair region. So this is a GIS map which I have prepared, which actually shows the track of these particular cyclones. See, this is Bay of Bengal. This is Indian mainland here in the left side. So you can see the IMD has classified cyclone into like cyclonic storm, depression, deep depression, severe cyclonic storm, very severe cyclonic storm. So this cyclone, particular cyclone originated here somewhere in the eastern region of Andaman and Nicobar Islands as a depression. Then it further intensified. And when it crossed the Port Blair region of Andaman and Nicobar Island, it was a cyclonic storm, and then it got intensified into very severe cyclonic storm and had a landfall in Andhra Pradesh. Okay, so basically, I wanted to know what was the risk associated with that particular cyclone. Okay, which areas are at risk in the Port Blair region? So this is my steady area. It's almost 184 square kilometer. Now I wanted to first to know the risk. I wanted to do two things, mostly three things: vulnerability, hazard, and mitigation capacity. So for vulnerability, I have selected these parameters. So I wanted to know, like, elevation. Elevation plays an important role when it comes to vulnerability of cyclones. Like high areas are like almost less exposed to cyclonic hazards, right? Okay, steep slopes are like highly dangerous. So then proximity to cyclone track, like when your region is very near to the track of the cyclone which is going, that is very dangerous. Then proximity to coastline. When you are very near the coastline, it is very dangerous. Land use, land cover, and population. I will show you all the maps which I have created. So this is a digital elevation model of the steady area. Here you see this red color are the low-lying regions. You can see this red color, and this one, this I don't know which color, this dark green or something, which is the highest elevated region. So these low-lying areas are basically when a cyclone passes, these regions are basically affected by the harmful impacts of it. Okay. Now proximity to coastline, if you see, these areas, the areas or people who are residing in this particular part are very much vulnerable towards the ill effects of cyclone. So we can create a map. This is a very simple vector map. I have just used this scaling measure like 1 to 2 kilometers. So basically what I'm saying, these red regions are less than 1 kilometer from the coastline so that they are affected. It's a very simple common logic that we have to apply. And here, this is where the cyclone track goes. So can you see my mouse which is moving?
Yes, we can.
Then it's fine. Yeah. So these areas were very dangerous because the cyclone track actually goes like this. So when the distance increases, basically your vulnerability decreases, right? That's the idea. This is a land use land cover. Land use land cover map of Port Blair. So here what I have seen, these agriculture lands, right? These ones for like agriculture lands are basically very prone to a cyclonic danger because they are basically low-lying areas. Okay. Now this is the population map of the steady area. So here this red color has the maximum population. So whenever there is a increase in population, for sure, the vulnerability is very high. Okay. Now I have created a vulnerability map. So you can see that this region is the highly vulnerable region. Similarly, I have created hazard mapping. Now I wanted to know, like I wanted to put every hazard into map. So as you said, the hazards associated with cyclones are cyclonic wind speed, precipitation, coastal flooding, and significant wave heights. There were waves which were coming to the coast. Okay. Now these are the wind speed. This is the wind speed which I represented into the GIS platform. This is the thing which I numerically modeled by using a software, and I added this to a GIS platform. Again, this is rainfall. This is coastal flooding due to storms. So there was a storm surge associated with the cyclone. That is also a hazard. Then I put that into GIS platform, and I know these were the areas which were actually flooded during that particular event. Now, these were the areas where high waves came, like from the coast. Then I got a hazard map. Then mitigation capacity, I wanted to map, put all the cyclone shelters over here. So if you have more number of shelters, your risk is less. And here, health facilities. So you can see this is the town area, like the major Port Blair area where all the hospitals are concentrated. Here, hospitals were less concentrated. Okay. Then everything put together, I got like risk is equal to vulnerability into exposure into hazard divided by mitigation capacity. I got my risk map. So basically this tell you this particular region, we called it as Sipigat region and all in Port Blair. Yeah, I exactly don't remember the name now. Sorry, I'm really sorry. So these areas are pretty much uh, high risky when a cyclone actually crosses. So this is an application where you can use GIS to understand the risk of a particular area. That's it about, yeah, are these maps are created in QGIS? Yes, yes. I usually uses QGIS because there are a lot of plugins you can use. Like it's very easy to use. People do say ArcGIS is easy to use, but once you are very familiar with QGIS, I think that is the, I mean, best option because like you don't have to pay for anything. You don't have to use a cracked software or something. Uh, Taking all parameters, how did you finally prepare a vulnerability map? Yeah, that's a very good question. So that's a very good question. Thank you so much for asking this. So in vulnerability, I told you, you have elevation, slope, proximity to cyclone track, proximity to coastline, land use and land cover. 1, 2, 3, 4, 5, 6, and 7. So there are 7 parameters. Now you don't know which parameter actually causes, like which parameter has more significance in determining the vulnerability. You don't know whether it is elevation, you don't know whether it is proximity to cyclone track. What is it? You really don't know. So you run a thing called as multi-criterion decision making thing. So it's a statistical technique. You can use that in GIS environment. I used a multi-criterion decision making tool known as AHP. That is called as analytical hierarchy process, where you combine everything, every parameters, elevation, slope, proximity, and according to the importance, you will give them a rank. Basically, you will find out, and talking to people, talking to expert, you will find out like whether elevation was playing a huge role or a slope was playing a huge role. I didn't put that here due to lack of time. Okay, for in my study, I could understand it was proximity to coastline and proximity to cyclone, which contributed towards like 40%. So then you add up everything in the ArcGIS environment or QGIS environment. Finally, you layer it up. Okay, I forgot the technical name for that. You overlay it. Yeah, you overlay it. There is a technique called as overlay. Then you can get. Okay. So what technique have you used in LULC classification? I use supervised classification, like where you take like it's a technique, like basically like you can use supervised classification for this. Yeah. Thank you so much, Tausif. Yeah, any other questions?
Hello?
Yeah.
Hello,
Raise the hand. I can see.
Is QGIS universally accepted? Yes, it is accepted. Yeah.
Then thank you. Was a doubt I had in my thank you for answering.
Sure, sure. Any other question? Feel free to reach out to me if you want to, if you have any doubt regarding vulnerability and all. I can definitely help you. Like this was like, I mean, you can't cover everything, every aspects of the uh, remote sensing in like 1 hour and all. So yeah, you can reach out to me anytime. So
Uh,
if you have got some doubts, I'm happy to
uh,
help you.
yeah, Than, your
Could I
hands are
convert
raised, please.
HDFI data? Yeah, to NetCDF. I think it is convertible. Yeah, NetCDF data
my
can be done.
question is already in chatbot.
Mm, uh, so if you can use like if you Koi Than, right? Yeah. So I'm talking about the NetCDF data sets. Uh, if you can use this Python libraries, that will be great. Like you can either use a matplotlib or something, then it will be more convenient to use for NetCDF formats. Yeah.
Yes, sir. Yes, because most of the satellite data
Yeah,
are
exactly.
come from
In
the
NetCDF,
HDF.
right?
Yes. So I would like to change our meteorological data is an SCDF. So
Yeah. So we
yeah,
basically were using some Python libraries for that. There are a lot of libraries like available. So are you using Python recently?
yes, I use
Yeah. I think
the
that will be
Python.
best, and the results can be interpreted in, because I also have tried NetCDF in QGIS and it was working. Yeah.
Okay. Thank you very much.
What
So
are the fields we use the software, sir?
what were I can't hear you properly. Sorry.
What are the fields we use the software, sir?
What are the field?
Yeah, yes, sir.
I mean, basically, as a disaster management person, I use basically this for like risk assessments, vulnerability assessments, etc. Yeah, that's how. So I can answer your question. How much we can, I mean, from this question itself, how much we can rely on remote sensing to seek pre-disaster information? That's a very good question. Thank you, sir, for asking that. So, what we can do now? Suppose I have prepared a. See, this is a digital elevation model of the steady area. So obviously, you know that these low-lying areas, right? This minus 1.43 meters to 20-meter areas are represented in red color, this red color. You know that when a flood comes or when a cyclone comes, these areas are intrinsically they are vulnerable, right? Because the water will come there first only. So you will have an idea of all these areas. Okay, these areas are going to be inundated for sure. Like if a 1 meter storm surge comes, you see like all the all the areas which are under 1 meter will definitely going to be inundated. So this is something we can have an idea before, even before a disaster strikes. So I have done this for a particular cyclone. Now any hello hello, can you
Yeah,
hear me?
yes, we can hear you.
Somebody muted me. Okay, I myself muted. I'm sorry. Okay, so for any other cyclones which will happen in the future, you can rely on this information. So then, yeah, how remote sensing can create databases of persons with disabilities and old age in order to rescue them during such disaster. For sure, we can create that. So if you have a shapefile, you can just, I mean, add that as a vector layer into your GIS platform for sure. And you can see like, suppose you have your municipal ward, and you can see the number of persons in each ward with disabilities. You have to get the census data, collect that in an Excel sheet. You can actually feed them into your database, and you can have a good map of it also. This is very much possible in GIS. I hope I have answered your question. Any other questions?
So for creating these maps, we need a internet operated software, okay?
I cannot actually get your question. Like your voice is breaking. Can you just type it down?
So
Land data
Uh,
pattern map standard, the replication of standard. I didn't get this question basically. I'm sorry.
like the land elevatory, I mean like the land data pattern, may we can replicate it
Yeah.
on the Indian map. I mean, like it's all about prevention, right? And
Yep.
when the land elevation matrices are patterns into clearly I'm not an expert, but it's just a thought I had in my mind. So
Yeah,
like
that
these
I think.
matrices can be applied on to real world Indian
Yeah,
map
yeah.
to for prevention
Yes.
purposes.
Yes. That's pretty much replicable for sure. Yeah. That is pretty much replicable. You can, there are a lot of, I mean, somebody asked this AI tools and all, right? You can basically create a lot of models by using this matrices, basically. Yes, it is doable. Yes.
Thanks.
AI tools. Yes, you can use, but I don't remember exactly which are the specific tools for that. I'm sorry. Yeah. Any other questions? Where I can apply the AHP method? AHP method can be, AHP is a decision making method basically. So there is a, you can do it in a simple Excel sheet, like creating these pairwise matrices and all. Yeah, that's pretty doable. And the results of the AHP method, you get some percentage values, right? For each factors which is contributing. You can add that in your QGIS or wherever by using raster calculator tool. Yeah, throughout
sir,
area data. Yeah, hello.
sir, for using this software, we need internet connection, sir, or without
No, no,
offline.
no, no. Like you have to download and you can use it offline. No need of internet connection.
Okay, sir.
And QGIS also helps you in like directly downloading some of the um, databases directly from them. Like for example, you can directly download. You don't have to go to satellite data portals. You can directly download any satellite, almost all satellites from QGIS screen itself. That's a very big advantage using QGIS. So this is also possible. You don't have to go to each site and look into the data. You can directly pretty much get all the data from the this QGIS data set itself. That's a very good advantage. I've been using this. So yeah. Any other questions? I think it's 5, right? We need to, yeah. Hello?
There is a question, can GIS help in generating broad area data?
Oh, okay. Sorry, I missed it. Yeah, definitely. GIS can help preparing in drought monitoring, especially when you monitor the vegetation patterns, when you monitor the hydrological patterns, uh, soil data. So for drought, there will be conditions, right? I mean, I am not an expert in drought, but definitely there will be condition. This much water level, if it has gone down, there is a probability of a agricultural drought. Or if the rainfall is less than this much, there is a probability of a meteorological drought. So according to the conditions, you can definitely make a drought area data from that. Yeah, for sure. But I have not done that. Yes. Mm, would the real-time contributions of OpenStreet maps will be available to QGIS. I hope it is available because that's they have been doing it like in a real time, right? So you need to
Yeah,
see the
so
keywords.
yeah,
I
exactly.
hope
Like
I
a
hope it is
real-time
available.
data trap monitoring is available.
I guess it should be available, Vishnu. Like that's the thing. Even
Uh,
I wanted to check it out. Like when you ask this question, no, I'm in a confused state. I have to check
right.
it out. Yeah, but it should be available because people voluntarily do that, right? Contribute to OpenStreetMaps, right?
Yes.
Sorry,
That's how it.
I am not an expert and I do not
I think that's
understand.
how it works. People, you can also contribute to OpenStreetMaps. Okay,
Yes.
then that thing, yeah, I think, yeah, then that thing can be available in this one. Yeah. From Panavel to Navi Mumbai? Was this? Was this a question?
I don't think so.
Okay, then it's fine. It's available, yeah.
Yeah.
Yeah. Hi, Gautam. Yes.
All right. Is there any other pressing questions? Anyone? Like a final call?
No, ma'am.
You can raise your hands or put in the chat box. Yeah.
Ashwati.
We'll take one more question.
Yeah,
Ashwati.
Ashwati.
Ashwati, can you hear us? You have raised your hand. Can you unmute? It might be some technical
Yeah, then, yeah,
issues.
sure,
Yeah. So, shall we close the session then?
sure.
Okay. So there's one more question in the chat box, so we'll take that also.
Is
Is
there
there
any app
any
available
app
for
available for common masses to remain updated about disasters?
There are apps, but right now nothing is actually coming into my mind. Common masses to remain updated about disaster using AI gadgets, right?
Yeah. If it's a
Mm,
real-time disaster information, maybe the IMD.
yeah, for if you are interested in this one, like to get the wind information and all, you can log on to windy.com where they can see real-time information about the ocean states and all. Like, have like this one, windy.com? Like, so here you can interpret some of the things like what is the current rain which is happening in your area. So yeah, this is a good software that you can use. Not a software, it's a web-based thing. There is an app also for it. You can see for the next 1 week or something. You can see if there is any cyclone which is coming. Yeah, winds. Let's see if there is any low pressure. I don't see any low pressures here. Yeah, this is how you can. I mean, this is a very simple platform where you can get about all the hydromet thing. There was one thing by NDMA. I forgot their name. Yeah. Thank you so much. Yeah. Bye.
All right. So I think we can close the session for today.
Yeah.
Uh,
NDMA has launched a system. Thank you, Gautam. Called as CAP. Yeah. They are giving real-time alerts. Yeah. Any other?
Yeah.
Mm. Yeah. So over to you, Hannah. Like.
All right.
Yeah.
So it was a very engaging session. So before closing it officially, I would like to extend a big thank you to Dr. Hamid for your time and all your preparations before taking
Thank
this
you so much.
session. I understand it is a challenge to do it in 1 hour, and you very much stick to the time. And also you showed us how to use it in a real time, and really a big thank you from all of us and on behalf of Sphere India Academy. And we have recorded the session and we'll be putting it up in the YouTube, and we'll send you all the recording. So
Yeah,
even
sure.
if we want to like refer to it later or share to more people. And thank you so much. We
Same.
really appreciate your time, and also to all the participants who joined on time and stayed throughout. Thank you so much. You please feel free to share your feedback here, or we'll also be sharing a feedback form later along with the recording. So feel free to share that, and also if you want similar sessions, please let us know. And that's it. And thank you, everyone.
Yeah,
Thank you, Dr.
thank you so
Thank
much. Thank you so much.
you so
Bye.
much.